Hello guys, we're gonna show you our experiment today.
This is gonna be something special since we love you so much. Some over live batteries. Let's head into Ms. Warner's room where tears are shed every day. Where hard work is paid off. Come on, let's go to the lab table. Let's go. Hey, welcome to Team Warner, where safety is our #1 priority.
Here, over here. Okay, so where did we get this wonderful idea from? We wanted to do something relating to electrochemistry, because that last unit was pretty fun.
Of our lab is to figure out which one of these fruits will provide us with most voltage and most electricity to light up the light bulbs. Also, our hypothesis is that it's gonna be the lemon because it's the most acidic and has most electrolyte.
So different from an actual dry cell battery you get from the store, which would provide you a positive and negative side. Difference in the potential is what drives the electron flow. In this case, what drives the electron flow is the zinc and the copper, because the copper is more electronegative, which means it wants electrons more than the zinc does, which is why it drives the electron, and the electrolyte also makes that happen. And if you want to use household items for your battery, for your electrodes, you can use a penny and a galvanized nail. The penny will provide you with copper, and the galvanized nail meaning it's coated with zinc, so you can use these for your electrodes. Okay, awesome.
Hey guys, so I'm gonna show you our experiment control variables, which is the light bulb, the wires, and the 2 electrodes, the copper and the zinc strips.
And our experimental variable is one of the fruits we have. First off, we have these lemons, which is always good. And then we have something I would like to call the Asian lemon, used for pho and stuff. Delicious. And then we have oranges, nice. And we have an eggplant, big juicy eggplant. Alrighty, so how we're going to measure the voltage of these fruits is that, let me introduce you to my beautiful technician translator. And he's going to show us our voltage drop by using Logger Pro. Using a voltmeter too, yeah.
Now we're gonna start our experiment. We're gonna go first with the lemon, and here we have the copper and the zinc. We're gonna stuck them in there. Okay, zinc, which acts as a anode. It's been oxidized, and the other one copper. On the other side is acting as a cathode, which is being reduced. And now we're gonna test the voltage of it here on the computer.
And now we're gonna
just stuck it on there.
Good.
Okay.
There you go.
There. See, now we have a voltage increase from 0.1 to 0.9 voltage.
We're gonna use the same procedure to do for the oranges. We're gonna put zinc, copper into orange, followed by zinc.
As you can see now, we're testing the orange.
And it went from 0.1 to
it's a little bit lower than
Slightly lower than the lemon.
Now it's gonna be the pho lemon, the Asian lemon. Also known as lime. I'll put the copper in, and then the zinc in. Voltage is 0.9. It's relatively equal to the lemon.
It's just in between the lemon and the orange.
Then the lime, yeah. Alright, now into a big boy. The eggplant. Very delicate little thing right here. Put on the electrodes, the zinc, and then the copper. Nice. You want the juice to be able to. You want it to be juicy, right? Putting 2 things on. Flip on one side, on the other. It seems that the big boy is the lowest.
Hey guys, so our lemon here has a 0.9 voltage, along with this lime is also 0.9. This one is about 0.8, 0.7 something, and this one is only 0.7. So, I mean, obviously size does not matter because this sometimes smaller is better.
We're gonna try to light up the light bulb with 1 lemon. And we actually 4 lemon, I mean. And then connect the zinc to the copper, and then copper to the zinc. Now we're just setting it up.
I need another one. We set it up in series. So from the copper
Yeah, there
to
we go.
zinc,
And then now here you see the
copper
light
to
bulb,
zinc.
and you see there. So you just connect these two. Put them on there. Looks like it's not working, but we're gonna see how much voltage it has and figure out what our problem is.
nice.
Get on there. Okay, so
3.8 and it's still not working. It's still not lighting up the light
It looks
bulb.
like it's relatively 4 times the amount of 1 lemon, so it's increasing proportionally.
Now we gotta do the oranges.
juicy.
The same procedure that Lynn did by sticking zinc,
Why are you copying Lynn, bro?
copper to the thing.
Stuck me in there.
Lead.
Just actually squeeze it a little bit.
You keep this PG-13.
Connect to the light bulb.
Light bulb. It hopes it will work. And no. Now we're gonna test the voltage.
How do you open
Good.
it there?
There you go.
Alright, there you go. 3.6.
It's 3.6. It's a little bit lower, but the light bulb is still not lighting up.
Guys, so now we're gonna set up all the fruits and see how much voltage we get. Let's go!
And
this
to
thing, and this
figure
thing.
out what's our problem that it didn't light up the light bulb, because we know that definitely we have enough voltage.
Definitely enough
Okay.
voltage, guys. Definitely
Okay,
enough.
now-
Let's go!
Okay, now set it up. Okay, now we're gonna plug it onto the light bulb. Okay. It's about time, guys. It's about time. It's happening.
happening.
Let's do it. Okay. Oh well. Things happens. Things happens. No, flip it. Flip it. Whoa, that's 6 voltage.
6.1, guys. 6.1.
So now we know
the
that
light bulb
we
still didn't
definitely
light
have
up.
enough voltage.
Went back here again, and so we now know that our problem is not the voltage,
Yeah, that's right.
current.
That's right. That's
Current
right.
is not flowing through well enough because internal resistance. These fruits are way too high, and it's not current flowing through it. It's not big enough for this resistor over here. And so we know that power. To get power, you need voltage and current, not just voltage. So even though we have enough current, voltage from the fruits, we're not getting enough current. So that's a big problem for this in real life application because it's not efficient, and that's why it would never work unless there's a way to alter it.
So from our experiments, we learned that just because we can produce an efficient amount of voltage doesn't mean we can produce enough power. And also, these bad boys are not just for eating, but they're also could produce electricity and give it enough current. You know?
Okay, so about experiments in general, experiments help us to learn more about the concepts and teach us and show us how that concept can be applied to real life and how it can be used in everyday life. Such as this electrochemistry, we can learn that how batteries work and how to make more efficient batteries and stuff like that.
And since the world tends to go towards entropy, an increase in entropy, even though we might not be able to stop that, maybe we can somehow slow it down or even alter it.
I Alright, thank you for watching, and
This has been another great episode of Team Warner.
Yeah. Next time,
This is us signing off.
next time we'll be testing electricity behind urine.